Assalamualaikum and hello. Today we will discuss about our mini project assignment, the principle of Lorentz law and DC motor. This project is grouped by Ahmad, Hafiz bin Mahzan and me, SYAHMI bin SAFIAN from BEEI1323. Principle of Lorentz law. Lorentz force or Lorentz law is described as a force acting on electric charge due to the magnetic and electric field. It is widely used in motor of simple electrical appliances. The formula of Lorentz force can also be derived as F equals to Q times E plus V times V, as a Q is electric charge, E is electric field, V velocity, and B is magnetic field. Fleming left-hand rule. The direction of Lorentz force can be controlled and determined, thus why it has been used in all kinds of motors. The direction of the force is by applying Fleming left-hand rule. Hold out your left hand with 4 fingers, second finger, and thumbs with the right angle to one and another. If the forefinger represent as a direction of field, the second finger is present current and the thumb is the present of thrust and motion. Fleming left-hand rule is simple and accurate way to find the direction of force motion of the conductor in the electric motor when the magnetic field direction and the current direction are known.
My name is Ahmad Hafiz, and so today I will talk about DC motors. A DC motor is an electrical machine that converts electrical energy into mechanical energy. In a DC motor, the input electrical energy is the direct current, which is transformed into the mechanical rotation. So, simple DC motor uses a stationary set of magnets in the stator and a coil of wire with a current running through it. So as you can see in the diagram, it shows that there is a permanent magnet, a stator as you will, and a coil wire in the middle of the magnet. So that is how simple DC motor looks like. So how does Lorentz law affects DC motors? So firstly, the current that flows through the coil of the wire generates their own magnetic field, meaning each charge or current that passes in the wire has their own magnetic field. And so the magnetic field of the permanent magnet will cause the coil of the wires to move because of Lorentz law and make it correspond with the magnetic field of the stator or permanent magnet. This is meaning that with their own magnetic field, they can be interrupted by other magnets that is near the coil wire. So, for example, a motor without external magnet is useless because it will has no force to move because it is stationary at where it's at. But if a magnet is placed near the coil wire, the wire will react by moving itself by using the Lorentz law as stated in the first slide, moving itself, making it correspond to the magnet's magnetic field, making it follow the magnetic field. So we can determine the force motion of the magnet by using Fleming's left-hand rule as stated by my friend AFIF. So for a better explanation, we can see the project that we built to demonstrate how simple DC motor works. So for our project, we have a magnet, a battery, and a coil wire, and 2 standing upright wires. Firstly, we take the coil wire and put it on the standing upright wires and put the magnet below it. And then we take the battery and we connect it to the wire, to the circuit I mean, and we will see how the coil wire spins around or rotate. To explain what is happening in this circuit, we will use Fleming's left-hand rule. So this is the direction of the current, and this is the direction of the magnetic field. By using Fleming's left-hand rule, we can conclude that the direction of the force or motion will be downwards towards the left or front side of the coil wire. And all of the motion in this experiment is due to the Lorentz law or Lorentz force. That is all from us. Thank you for watching.